Somewhere in the cold vastness between the stars, an object drifted silently through space. It came from beyond our solar system, passed near Earth's orbit, and continued on its journey into the outer darkness. This designation, 3I/Atlas. To most, it was just another entry in an astronomical catalog. But to some observers, something felt different. Questions emerged. Why wasn't it discussed more? Why did coverage seem muted? Tonight, we explore a cosmic visitor that sparked curiosity and suspicion in equal measure. Not through sensational claims, but through careful examination of what we know, what we don't, and why the human mind searches for hidden meanings in the silent trajectories of interstellar wanderers. This is the story of 3I/Atlas, and the mystery surrounding what should have been a simple astronomical discovery. To understand the questions surrounding 3I/Atlas, we must first understand what it is. The designation itself tells a story. The I stands for interstellar, an object not bound to our sun's gravity. The 3 means it was the third confirmed interstellar object detected passing through our solar system. Atlas refers to the Asteroid Terrestrial Impact Last Alert System, the survey program in Hawaii that first spotted it. These objects are incredibly rare. For most of human history, we never detected any. Every comet, every asteroid we observed belonged to our solar system, trapped in endless orbits around our sun. Then something changed. In 2017, astronomers spotted Oumuamua, the first confirmed interstellar visitor. 2 years later came 2I/Borisov, and then 3I/Atlas appeared in 2024. The rarity of interstellar objects cannot be overstated. Our solar system is vast, but space between stars is incomprehensibly larger. For an object to pass through our cosmic neighborhood requires precise conditions. It must be ejected from another star system with enough velocity to escape that star's gravity. It must travel through the void for thousands or millions of years. And it must happen to cross paths with our tiny region of space at exactly the moment we're looking. The odds are astronomical, yet here we are detecting several within just a few years. This sudden discovery pattern itself raises questions. Are they actually becoming more common? Or have our detection capabilities simply improved enough to finally see what was always passing through? Before we examine the mystery, we need context from the first interstellar visitor. Oumuamua arrived in October 2017, tumbling through space at over 87 kilometers per second. Its appearance was strange, elongated, cigar-shaped, or perhaps disc-like, depending on interpretation. What made it truly unusual was its trajectory. As it swung around the sun and headed back into deep space, it accelerated slightly, more than gravity alone could explain. This tiny acceleration sparked intense debate. Outgassing from a comet? Perhaps, but no comet-like tail was visible. Some proposed exotic explanations. The scientific community remained divided. Oumuamua left our system before detailed observations could resolve the mystery. It set a precedent for how we react to interstellar visitors, with fascination, speculation, and sometimes suspicion. The second confirmed visitor, 2I/Borisov, arrived in August 2019. Unlike its predecessor, Borisov behaved exactly as expected. It was clearly a comet, with a visible tail of gas and dust streaming behind it as the sun's heat vaporized its ices. Its composition appeared similar to comets in our own solar system. Spectrographic analysis revealed water vapor, carbon monoxide, and other familiar compounds. Astronomers observed it extensively, tracking its path through the inner solar system and back out into interstellar space. Borisov was unremarkable in the best possible way. It confirmed that at least some interstellar objects are exactly what they appear to be, natural cosmic debris wandering between the stars. It showed that not every visitor need be mysterious. Yet the memory of Oumuamua's oddities lingered. Then came 3I/Atlas. Initial detection occurred in early 2024 by the automated survey system. The object appeared first as a faint point of light moving against the background stars. Follow-up observations confirmed what preliminary data suggested. This was another interstellar visitor, following a hyperbolic trajectory that would carry it through our system and back out into the galaxy. Early reports described it as small, perhaps a few hundred meters across, moving at approximately 30 kilometers per second relative to the Sun. These details emerged gradually as more observatories turned their attention toward it. But compared to the excitement around Oumuamua and the thorough observation of Borisov, something felt different. The public reception was quieter, media coverage less prominent, and this quietness, paradoxically, became loud to those listening. When news of 3I/Atlas began circulating in astronomical circles, the initial response was measured excitement. Here was another data point, another chance to study an object from beyond our solar system. Professional astronomers shared preliminary findings through proper channels. Research papers, conferences, astronomical telegrams. This is how science normally proceeds. Careful, methodical, peer-reviewed. But in the age of instant information, some observers expected more. They expected headlines, press conferences, public excitement matching the previous visitors. When that didn't materialize at the expected volume, questions emerged. Was this object somehow less interesting? Or was there another reason for the relative silence? The absence of noise began to sound like secrecy to ears trained to hear conspiracy in every quiet moment. To understand why some felt 3I/Atlas was hidden, we must examine how astronomical discoveries actually reach the public. When an object is detected, it goes through verification. Multiple observations confirm it's real, not an artifact or error. Trajectory calculations determine its origin and path. Then comes publication, typically through astronomical circulars, specialized databases, and eventually research papers. The media may or may not pick up the story, depending on perceived public interest, competing news, and whether the discovery offers a compelling narrative. 3I/Atlas followed this standard process. It was announced through proper channels. Data was shared with the astronomical community, but it didn't capture widespread media attention. Not every discovery does. The question is whether this was natural variance in media interest or something more deliberate. Let us examine what we actually know about 3I/Atlas from verified sources. The object's trajectory has been calculated and published. It entered the inner solar system from the direction of the constellation Auriga. Its path showed clear signs of an interstellar origin. The orbit was not elliptical but hyperbolic, meaning it was not bound to the Sun's gravity and would escape our system entirely. Observational data suggested it was relatively small, likely a few hundred meters in diameter, composed of rock or possibly ice. No signs of active outgassing or a comet tail were reported in initial observations, though this could be due to its small size or composition. These are the facts as published in astronomical databases. They are available to anyone who knows where to look. Yet many don't know where to look, creating an information gap that feels like secrecy. Comparing the 3 known interstellar objects reveals interesting patterns. Oumuamua was the groundbreaker, the first of its kind, arriving when we weren't expecting such visitors. Its unusual shape and acceleration made it inherently mysterious. Borisov was the confirmation, proving that interstellar objects could be ordinary comets. 3I/Atlas falls somewhere between another visitor, but one that arrived after the novelty had worn off. By the time of its detection, the pattern was established. Interstellar objects exist. They sometimes pass through our system. This normalization might explain reduced public interest. What was once extraordinary had become, in some sense, expected. Yet this very normalization strikes some as suspicious. How quickly we accepted these visitors. How easily we moved on from each one, as if we were being gradually accustomed to something larger. The trajectory of 3I/Atlas carries specific information. Objects moving through space follow paths determined by gravity, the sum of forces from the sun, planets, and their own momentum. When astronomers calculate an orbit and determine it's hyperbolic rather than elliptical, this reveals the object came from interstellar space. The mathematical certainty of orbital mechanics leaves little room for error. 3I/Atlas's path was confirmed by multiple observations from different observatories, eliminating the possibility of miscalculation or misidentification. Its velocity and direction indicated it had been traveling through space for an unknown time, possibly millions of years, before entering our solar system. The trajectory also predicted when it would leave, following a path that would carry it back into the vast distances between stars. These calculations are publicly available, published in astronomical databases accessible to researchers worldwide. Orbital mechanics is an exact science. When an object passes through our solar system, its path can be predicted with extraordinary precision. The position of planets, the sun's gravity, even the minor gravitational influences of asteroids, all these factors combine to determine where an object will go. With 3I/Atlas, these calculations showed something unremarkable in one sense. A simple hyperbolic escape trajectory, just as expected for an interstellar visitor. But within that simplicity, some observers claimed to find significance. The object's path brought it relatively close to Earth's orbit, though not dangerously so. Some noted that its trajectory seemed almost designed to avoid close encounters with major planets. These observations are factually accurate. The interpretation of meaning behind them is where science ends and speculation begins. What did official astronomical sources say about 3I/Atlas? The International Astronomical Union's Minor Planet Center published the detection and initial orbital elements. NASA's Center for Near-Earth Object Studies included it in their databases. Several professional observatories released images and spectroscopic data. Research papers began appearing in astronomical journals, analyzing its properties and trajectory. The tone of these official communications was measured and technical, as is standard for scientific publications. They presented data, discussed uncertainties, and proposed follow-up observations. There was no sense of alarm, no indication of anything unusual beyond the simple fact that another interstellar object had been detected. For the scientific community, this was exactly what the process should look like. For some outside observers, this measured response felt too controlled, too calm, as if something was being managed. Media coverage of 3I/Atlas was notably lighter than for previous interstellar visitors. A few science news outlets published articles explaining the discovery. Some astronomy websites discussed its properties and trajectory, but mainstream media largely ignored it or relegated it to brief mentions. This disparity in coverage compared to Oumuamua sparked discussion. Why such a difference? Several explanations are possible. By the third interstellar visitor, the novelty had diminished. What was once unprecedented had become a known phenomenon. The object itself was less mysterious than Oumuamua, lacking unusual features to capture public imagination. Media cycles move quickly, and competing news may have overshadowed an astronomical discovery. Or perhaps, as some suggested, there was less enthusiasm for promoting the story. The reason matters because in the absence of clear explanation, people fill the gap with their own theories. We must consider the psychology of information flow. In the digital age, people expect immediate, comprehensive coverage of significant events. When a story doesn't receive the attention observers believe it deserves, several interpretations are possible. The first is that the story simply isn't as significant as assumed. Professional news judgment determined other stories were more important. The second is that public interest genuinely wasn't there. Audiences didn't engage with early coverage, so media outlets moved on. The third is that something prevented wider coverage, editorial decisions, external pressure, or coordination to minimize attention. Without insider knowledge of newsrooms, we cannot know which explanation is accurate. But human nature tends toward the third option when mysteries are involved. It's more satisfying to imagine hidden hands controlling information than to accept that sometimes stories just don't catch on. Public reaction to 3I/Atlas divided along predictable lines. Professional astronomers and space enthusiasts noted the detection with interest, discussed its properties, and waited for more data. This group understood the discovery as part of an ongoing scientific process, one more data point in our growing understanding of interstellar objects. Another segment of observers, however, saw something more. They noticed the reduced media coverage and interpreted it as suppression. They pointed to the object's properties and found significance in every detail. Online forums filled with discussions about what was being hidden and why. The object became not just an astronomical phenomenon but a symbol, a focal point for broader distrust of official narratives, scientific institutions, and the assumption that we're told everything. These interpretations weren't necessarily irrational given their underlying premises, but those premises themselves required examination. Internet theories about 3I/Atlas followed familiar patterns seen in previous astronomical mysteries. Some suggested the object was artificial, perhaps a probe from an advanced civilization, with its true nature being covered up to prevent panic. Others proposed it was a natural but extraordinary phenomenon whose implications were too disturbing to share publicly. Some claimed access to leaked data showing unusual properties not in official reports. These theories spread through social media, forums, and YouTube videos, often presented with dramatic narration and ominous music. The specific claims varied, but they shared common elements. Official sources were lying or withholding information. The truth was being hidden for vague but sinister reasons, and only independent researchers brave enough to ask questions could reveal reality. These narratives are emotionally satisfying but require believing that thousands of professional astronomers worldwide would maintain perfect silence about extraordinary discoveries. Why do secrecy narratives emerge around astronomical discoveries? Several psychological factors contribute. First, space itself is mysterious. It represents the ultimate unknown, making it easy to project fears and fantasies onto cosmic phenomena. Second, there's a historical precedent for governments withholding information, creating generalized distrust that extends to all institutions. Third, scientific communication is often technical and cautious, which can feel like evasion to those expecting definitive answers. Fourth, there's a cognitive bias toward seeing patterns and meaning in randomness. Humans are pattern-seeking creatures, and we're uncomfortable with the idea that sometimes things just are without deeper significance. Finally, there's the appeal of feeling you possess secret knowledge others lack. Believing you see through deception grants a sense of superiority and insight. These factors combine to create an environment where even straightforward discoveries can become centers of suspicion. The concept of hidden knowledge has deep roots in human culture. Ancient mystery cults promised secret wisdom to initiates. Alchemists claimed to possess transformative knowledge concealed from the masses. Secret societies allegedly controlled history from behind the scenes. This tradition continues in modern conspiracy thinking, where the world is divided between those who know and those who remain ignorant. Astronomical mysteries tap into this archetype because space literally represents what's hidden from easy view. We cannot casually verify claims about objects millions of kilometers away. We must trust instruments, calculations, and the people operating them. For those predisposed to distrust, this creates an opportunity for doubt. Every astronomical discovery becomes potentially suspect. Every official explanation potentially a cover story. The question is how to distinguish between healthy skepticism and reflexive paranoia. Let us pause at this midpoint to assess where we stand. We've examined what 3I/Atlas is, an interstellar object detected by standard astronomical survey systems. We've reviewed its properties. A small body following a hyperbolic trajectory through our solar system. We've noted the official response. Measured scientific analysis published through normal channels. We've observed the public reaction, ranging from casual interest to deep suspicion. We've explored psychological factors that make people prone to seeing secrecy in gaps of information. Now we must turn to harder questions. Is there any legitimate reason to doubt the official narrative? How transparent is astronomical research actually? What mechanisms exist for verifying claims? And ultimately, how do we think rationally about mysteries when we lack expertise to evaluate technical evidence ourselves? These questions have no easy answers, but examining them carefully is the only path toward clarity. To evaluate claims that 3I/Atlas is being hidden, we must understand how astronomical data actually works. When an object is detected, the raw observations are typically shared with the astronomical community immediately. Images, positional measurements, and spectroscopic data go into public databases that anyone can access. Other observatories can then make their own observations to verify and expand on the initial findings. This system is designed specifically to prevent any single entity from controlling information. Even if one organization wanted to hide data about an unusual object, others would detect and publish it independently. The distributed nature of modern astronomy makes comprehensive cover-ups nearly impossible. This doesn't mean mistakes or misinterpretations can't occur, but coordinated deception requires assuming a level of global cooperation among thousands of independent researchers that simply doesn't exist in practice. Space agencies like NASA, ESA, and others have protocols for releasing information. For routine discoveries, data flows through standard scientific channels. Telescopes observe, researchers analyze, findings are published in journals, press releases follow for particularly interesting results. For extraordinary discoveries with potential public impact, there are additional review processes. But these reviews are about verifying findings before public announcement, not suppression. The goal is avoiding false alarms or premature claims, not hiding truth. Historical examples support this. When the first exoplanets were discovered, the findings were published and celebrated. When gravitational waves were detected, the discovery was announced with fanfare. When potentially habitable worlds are found, NASA holds press conferences. The pattern is toward transparency, not secrecy. If 3I/Atlas had extraordinary properties, the incentive structure of modern astronomy rewards rather than punishes those who reveal them. Consider the logistics of hiding astronomical information in the modern era. Thousands of professional and amateur astronomers worldwide monitor the sky nightly. Data from major surveys is often publicly available. Anyone with appropriate equipment can make observations and publish findings. Academic careers are built on discoveries, not on maintaining silence. Scientists in different countries working for different institutions with different funding sources and political systems would all need to coordinate perfectly to suppress information. The scenario requires not just a conspiracy but an impossibly competent one, spanning national boundaries and overcoming professional incentives. It's far more plausible that when coverage seems sparse or data seems limited, it's because the object simply wasn't that unusual, rather than because thousands of astronomers globally conspired to hide the truth about something they'd normally be eager to publish and claim credit for discovering. Some argue that not all secrecy requires active conspiracy. Perhaps there's simply institutional inertia or unspoken understanding about what to emphasize. This is a more reasonable position than claiming active cover-up. It's true that what gets attention is partly shaped by peer pressure, funding priorities, and establishment views. If an observation challenges prevailing theories too directly, it might receive less attention initially while scientists work to understand it. This is the nature of conservative scientific practice, which sounds sinister when called suppression, but is actually just being careful before making bold claims. The question is whether this conservatism crosses into bias that prevents true anomalies from being recognized. With 3I/Atlas, there's no evidence of even this softer form of suppression. The object was announced, tracked, and analyzed according to standard procedures. If fascinating properties were discovered, they would be published. The simplest explanation remains. It was simply another interstellar visitor, similar to but less remarkable than Oumuamua. Let us address specific claims made about 3I/Atlas in online discussions. Some claimed its trajectory was too perfect to be natural, suggesting artificial guidance. However, orbital mechanics is deterministic. Objects follow predictable paths based on their velocity and the gravitational fields they encounter. Any trajectory can be made to sound suspicious if you emphasize certain aspects. Others claimed the object's size estimates were inconsistent, suggesting data manipulation. Size estimates for distant, small objects are indeed uncertain and require assumptions about reflectivity and composition. Variations in estimates reflect this uncertainty, not cover-up. Still others pointed to the lack of detailed images as suspicious. Yet getting high-resolution images of small, distant objects is technically challenging even with the best telescopes. The absence of such images is normal, not evidence of suppression. Each specific claim, when examined, has a mundane explanation grounded in the realities of astronomical observation. There is a larger pattern worth noting in how fringe theories about astronomical objects develop. First comes the discovery, then early information, often incomplete because observations are ongoing. This gap between discovery and comprehensive understanding creates space for speculation. As speculation builds, the absence of immediate, complete explanation gets interpreted as evasion. Alternative theories emerge, often more exciting than reality. When official sources later publish full analysis showing the object is unremarkable, believers in alternative theories claim the analysis is fabricated or that the interesting data is being omitted. The cycle reinforces itself. Every official explanation becomes further proof of conspiracy. Every mundane detail is seen as a limited hangout, and the hypothesis becomes unfalsifiable. This pattern repeated with Oumuamua, with various exoplanet discoveries, with unusual transient astronomical events. 3I/Atlas simply became the latest focus of this recurring dynamic. We should acknowledge that institutional science is not perfect. Mistakes happen. Biases exist. Economic and political pressures can influence what research gets funded and published. Scientists are human, subject to peer pressure, career concerns, and cognitive biases like everyone else. There have been historical cases of scientific consensus being wrong, of contrarian voices being dismissed before being vindicated. Skepticism toward authority, including scientific authority, has legitimate foundations. The question is how to channel that skepticism productively rather than letting it curdle into reflexive disbelief. Productive skepticism asks for evidence, examines methodology, and updates beliefs based on new information. Reflexive disbelief treats all official claims as suspect and interprets every gap in evidence as proof of conspiracy. The former is the foundation of science itself. The latter is science's dark mirror, superficially resembling critical thinking but actually preventing learning and understanding. If we assume for a moment that there was something genuinely unusual about 3I/Atlas, what would we expect to see? Probably not silence, but rather intense, confused, contradictory discussion among astronomers as they tried to make sense of anomalous data. Science advances not through unified cover-ups, but through researchers competing to explain strange phenomena. If the object showed signs of artificial origin, numerous teams would rush to publish analyses supporting or refuting that hypothesis. If its composition was bizarre, chemists and planetary scientists would debate implications. If its trajectory defied known physics, specialists in orbital mechanics would work frantically to explain the discrepancy. The expected pattern would be noise, not silence, multiple papers, competing interpretations, heated conferences. The relative quiet around 3I/Atlas after initial detection suggests not cover-up, but rather that there simply wasn't much more to say beyond. Here's another interstellar object, similar in most ways to what we've seen before. Amateur astronomy plays an important role in this discussion. Dedicated amateurs with quality equipment observe the sky independently of official institutions. They've contributed to asteroid discovery, supernova detection, and exoplanet characterization. If there were obvious anomalies in official claims about 3I/Atlas, amateur observers could potentially verify or refute them. The fact that amateur astronomical community hasn't raised major alarms about inconsistencies is relevant evidence. This doesn't mean amateurs couldn't be wrong, or that they observe everything professional instruments can see, but it provides an independent check. Similarly, international observers outside major space agencies could detect significant anomalies. The community of sky watchers is large, diverse, and loosely organized. Keeping everyone aligned with a false narrative would be extraordinarily difficult. The distributed nature of modern observation is the best safeguard against institutional deception. Let us consider motivation. Why would space agencies or astronomical institutions hide information about 3I/Atlas? Common theories suggest preventing panic if the object were dangerous or artificial. But the object's trajectory was publicly published, allowing anyone to verify it posed no threat. If it showed signs of artificial origin, the discovery would be historically significant, the kind of finding careers are made on. Scientists would want to publish and claim credit, not remain silent. Perhaps governments would pressure for secrecy for national security reasons? But astronomical data comes from many countries, including some with tense relationships. Coordinating silence across national boundaries, especially when claiming the discovery would bring prestige, seems implausible. The motivations for transparency, career advancement, scientific reputation, national pride in discovery, far outweigh nebulous motivations for secrecy. Unless we posit motivations we're not aware of, the incentive structure points toward disclosure rather than hiding information. We've spent considerable time examining why people might believe 3I/Atlas is being hidden. Now we must address the central question directly. Is there credible evidence for this claim? Evidence would include documented cases of data being withheld from standard databases, whistleblowers from observatories claiming pressure to alter findings, discrepancies between observations from different sources suggesting data manipulation, or published analyses that contradict official claims in significant ways. Searching for such evidence yields essentially nothing. Data about 3I/Atlas appears in standard astronomical databases. Multiple observatories contributed observations. No whistleblowers have emerged. Independent analysis matches official findings within expected margins of uncertainty. The absence of positive evidence for cover-up is not proof that no cover-up occurred, but it shifts the burden of proof onto those making the claim. Extraordinary claims require extraordinary evidence, and the evidence for hiding information about 3I/Atlas remains, at best, circumstantial interpretation of normal patterns in media coverage and public communication. Debunking is often framed as defending establishment narratives, but this framing misses the point. The goal is not defending any particular position but evaluating evidence honestly. If compelling evidence emerged that 3I/Atlas had unusual properties being suppressed, honest evaluation would require taking that seriously. But we must also honestly acknowledge when claims lack support. The claim that 3I/Atlas is being hidden rests on reduced media coverage compared to expectations, perceived lack of detailed public analysis, and general distrust of institutions. The first two have straightforward explanations in the realities of news cycles and technical astronomical work. The third is a prior belief, not evidence of anything specific to this object. None of these points toward actual suppression. They point toward the gap between how astronomical research works and how some people expect it to work. A gap in understanding rather than evidence of conspiracy. Let us address one more specific concern raised about 3I/Atlas. The claim that follow-up observations were strangely limited. After initial detection, some observers expected extensive tracking campaigns and detailed study, as occurred with previous interstellar objects. When such extensive campaigns weren't highly publicized, suspicion arose. However, we must consider resource allocation. Telescope time is precious and allocated based on scientific return. Oumuamua received extensive attention because it was unprecedented and showed anomalous acceleration. Borisov received significant observation because it was the first interstellar comet. By the time 3I/Atlas appeared, the phenomenon was better understood, and the object showed no particularly unusual features in preliminary observations. Scientists made rational decisions to allocate resources to other questions while still collecting sufficient data to characterize 3I/Atlas. This is normal scientific prioritization, not evidence of hiding information. Every non-observation of something expected becomes suspicious only if you begin with the assumption that something is being hidden. There is an interesting meta-question here about the nature of proof and skepticism. Those who believe 3I/Atlas is being hidden will likely interpret everything written here as either naive acceptance of official stories or active participation in cover-up. This is the nature of unfalsifiable beliefs. They interpret all evidence through their lens. If data supports their view, it confirms their suspicions. If data contradicts their view, it proves the cover-up extends to that data. This creates an epistemological dead end where no evidence could possibly change the belief. True skepticism, by contrast, must be capable of updating beliefs based on evidence. It asks, what would convince me I'm wrong? If the answer is nothing could convince me, that's not skepticism but faith. Examining 3I/Atlas requires honest grappling with this question. What evidence would demonstrate it's not being hidden? If we can answer that and then look for such evidence, we're thinking clearly. If we cannot even imagine evidence that would change our view, we've left the realm of rational inquiry. Perhaps the truth about 3I/Atlas is simply mundane. It's the third interstellar object we've detected, arriving in an era when such detections are becoming routine. It showed no obviously anomalous properties in initial observations. Professional astronomers noted it, tracked it, published data, and moved on to other questions. Media covered it proportionally to perceived public interest, which was lower than for previous visitors because the novelty had worn off. No conspiracy, no cover-up, no hidden truth, just the normal functioning of astronomical research and science communication. This explanation requires no elaborate coordination, no suppressed evidence, no motivated reasoning. It fits the pattern of how science usually works. It may be less exciting than alternatives, but excitement is not a measure of truth. Sometimes the boring explanation is correct. Sometimes there's no mystery beyond what we project onto gaps in our understanding. The question is whether we can accept that, or whether the need for hidden meaning will always find expression. There is value, however, in the questions raised even if the conspiracy theories themselves are unfounded. The discussion around 3I/Atlas highlights real issues in science communication. The gap between technical research and public understanding is real and problematic. When discoveries are announced through specialized channels using technical language, many people feel excluded from knowledge that concerns humanity's place in the universe. This creates resentment and distrust that conspiracy theories exploit. The solution is not to suppress questions, but to improve communication, making astronomical data more accessible, explaining uncertainties more clearly, and meeting public curiosity with patience rather than dismissal. Scientists sometimes forget that what's routine to them is mysterious and exciting to others. That communication gap, not any actual cover-up, may be the real problem exposed by the 3I/Atlas controversy. As our examination draws toward conclusion, what can we say with confidence about 3I/Atlas? We can confirm it was detected by automated survey systems in 2024. Its trajectory indicated interstellar origin, making it the third such object confirmed. Observations by multiple facilities produced consistent data about its size, velocity, and path. This data was published in standard astronomical databases and discussed in specialized literature. Media coverage was lighter than for previous interstellar visitors, but not absent. No credible evidence supports claims of suppressed data or hidden anomalies. The most parsimonious explanation, that this was simply another interstellar visitor, less remarkable than its predecessors, fits all available evidence. Does this mean nothing unusual could possibly be true about the object? No, we must remain open to new data. But it does mean that current evidence doesn't support claims of cover-up, and extraordinary alternative theories require extraordinary support they don't currently possess. The story of 3I/Atlas is, in some ways, a story about ourselves. about how we process information in an age of overwhelming data but limited expertise, about how we navigate trust when institutions are imperfect but alternatives are worse, about how we balance healthy skepticism with the need to accept some authorities on complex technical matters we cannot verify personally, about how we manage the anxiety of living in a vast universe we're only beginning to understand. The object itself may be mundane, but our reaction to it reveals something about human nature. We want the universe to be full of mysteries and meaning. We want to believe we're on the cusp of revelations. We want the story to be more than it appears. These desires are natural and, in moderation, healthy. They become problematic only when they override evidence, when wanting something to be true blinds us to reality. There is a deeper fear beneath these questions about hidden astronomical objects. It's the fear of insignificance in a vast cosmos, the fear of being lied to by those we depend on for truth, and perhaps most fundamentally, the fear of a universe that doesn't care about us. If 3I/Atlas is just a rock, if interstellar visitors are common and unremarkable, if space contains no messages for us and holds no special place for humanity, that's a harder truth than the idea that something extraordinary is being hidden. The conspiracy narrative, in a strange way, is comforting. It means something important is happening, we're part of a significant story, and the universe is engaging with us even if only through secrecy. The alternative, that we're observing an indifferent cosmos that occasionally sends debris our way with no meaning or message, is starker and lonelier. Which reality we prefer doesn't determine which is true. And so we reach the end of this exploration, standing where we began but perhaps with clearer sight. 3I/Atlas passed through our solar system, was observed by astronomers, and continued its journey into the darkness between stars. Whether it was hiding something or whether we project mystery onto neutral phenomena, each person must decide for themselves. What we can say is this: the evidence for cover-up is thin, the mechanisms for maintaining such secrecy are implausible, and the mundane explanation fits what we observe. Yet the questions persist, and in some way they matter more than the object itself. They speak to our relationship with truth, authority, and the unknown. As the universe reveals itself gradually through observation and reason, we stand at the border between knowledge and mystery, trying to see clearly while acknowledging how much remains beyond our sight. The stars continue their ancient paths. We watch and wonder, and sometimes perhaps that wondering is enough.